to well, we're not recording right now, but you do have to put this in for the camera.
Okay.
Oh.
Forwarding. Just in case that's just to experimentally try it.
I'm shutting this down. Nothing I need.
Okay, could you give me 1 second and then I'll verify that I got that email?
Sure.
We are slightly stuck over here, but it looks like I can try sharing the whole desktop too.
Yeah, that was going to be my next suggestion.
Yep.
Mm. Have you just been like presenting like slideshow, or have you been doing something different?
I clicked the slideshow button there, so like just basically the same thing.
Yeah.
We'll pause. See if I get email. Email. Zoom record. So I'm going to double check the microphone here now too. I don't see that microphone. Yep. If we don't use this, do you think that's okay?
Beg your pardon?
If we don't use this, is that all right?
Okay, sure.
I think she's going to go check the sound outside and everything. And come back and give me. Sounds good? Okay, so we'll share or start the thing again, just for fun.
So Google has sent me something back asking for permission.
Thank you. Yeah, and actually I still need to get back to your thing here.
I honestly don't see it.
Well,
So
let me
I'm
check
gonna
again
spin.
and see if I got the PDF. Because we were just doing this other thing, so.
Put it on thumb drive too.
Yeah, it's.
What'd you find?
It's,
Anything?
no, it just is waiting for an email from, or for the approval of that Google request. So that should be in your email somewhere.
Yeah, that's the magic word, isn't
I
it?
know, yeah.
So where did they put it?
Or we can do this.
Okay, people are starting to arrive now. Do you want to delay it by 5 minutes or so? When we did have 100 people reserve tickets.
Yeah, sure. Yeah, sure. I mean, however. I think, yeah, we'll see how, I mean, we still have, yeah.
The problem is traffic to get it all.
Oh, that's true. Yeah.
It's Friday.
Sure.
It's a problem we have at the Planetarium. Usually it's our 5:30 show that has fewer people, but usually that's other stuff.
Did your device come up?
Device is right here. So you can, is it this intro?
Yeah. So you get some feedback on the two microphones, huh?
That other microphone wasn't showing up. So at this point, I'm just kind of, everything else is okay.
Okay. Well, young people, how are you? Thank you so much for coming out and braving the weather. This is what we're talking about too. Right?
So they, Celeste is letting them know it'll be 5 minutes. 5 minutes.
5 minutes, okay.
And if it's all right with everybody, so we want to make sure that 100 people reserve tickets, so. Yeah.
Wash your mask here.
Yes.
The solar cells.
Yeah. Not voluntarily, sounds like.
It's hard. Some people have the problem. Strong, resilient, maybe strong. That's the small.
You should sit right on.
How's that back row right there? Oh, here's some kissing back there. That's what goes on with that. Walk out the door. 6 minutes. Pardon? It was the third showing of Bonnie and Clyde. I sat through 2 of them. And Bonnie and Myers got to revisit. Do you know Tyler Nordgren?
I don't know him personally. No, I know of him.
Yeah. The dynamo.
Do you do some parties in the east part of the state too also?
I don't go that far. I usually go to Central. I have done for the International Dark Sky Association. I have done talks all the way over to Spokane.
Mm-hmm.
I haven't been down to Walla Walla yet, but I do talks in Spokane and the Tri-Cities.
Mm-hmm.
Do you need a laser at all?
I don't think so.
There's one right here.
Okay.
So if you need it, it's available. Thank you for opening that up for me. I appreciate it.
Sure. I'm just trying to get this one going here now. Again.
Pretty.
Mm-hmm.
Do you want to turn the lights down just a skosh more? Or do you
Yeah, whatever you think would be good for this sort of level. Oh, let's see. That's the problem. Do you know if Celeste is seeing the right view here?
She did see that you were doing stuff.
or the people online actually, because I can't quite check it. But we can get started other than that.
I did volunteer you to some of these people that brought NASA paraphernalia, and I told them that you would be signing autographs
All right.
after the show.
Yeah, sure. Sign autographs, all kinds of things. All right. Okay, we're good to go. Great. I'm just going to start since you all are ready. Okay. All right.
I just want to welcome everybody to the University of Washington's Astronomy Department Outreach Education Programs. We got a number of programs, the Planetarium, the Observatory, League of Astronomers. This is brought to you today by the Planetarium in conjunction with the Seattle Astronomical Society. Thank you very much. We are fortunate to have Dr. Liz McDonald with us this evening. She is an astrophysicist at NASA Goddard and a UW alum, physics department grad, and a native of Washington. And she studies the aurora, plasma coming from the sun, storms from the sun that generate aurora. She'll tell you more about that. And when she was at Los Alamos Laboratory, she saw during a large geomagnetic storm in 2011, she discovered Twitter. And all those aurora chasers out there talking to each other and posting what they're seeing. And she recognized this as a wonderful opportunity to have citizen scientists contribute their observations to real scientists so they can discover more. One of the things that's really amazing and wonderful about astronomy is that citizens have been making contributions for decades, and it's wonderful that you can actually make a contribution to science just through your hobby. Auroras are beautiful, those colorful dancing lights. I was inspired when I was a kid and saw them. I think you probably were too, but through your dad. And at this point, I'm going to stop talking and let Liz take it away. Thank you.
Hi. Thank you. Thank you so much. It's so exciting to be here. I really hope everyone in the room and online can hear us and see us. Very excited to be here. I was in your seats many, many years ago as a student here. My very first physics class was here in this room, and it was very difficult, but I'm here now, and we're all back here, so that's great. I'd like to start with this quote about aurora from an astronaut. I'm not an astronaut, but I think this is a great quote. You know, if you're an astronaut and you go to space, this is the burrito of awesomeness smothered with green awesome sauce that you can see up there in space. And it moves. And you can also see it here on Earth. So that's what I'm going to be talking about today. I do have a project that everybody can participate in called Aurorasaurus. It is sponsored by NASA Goddard, the New Mexico Consortium, and the National Science Foundation. And way back in the day, I was a student here. This is a long time ago, you know, but some things don't change. I just saw the peanut outside, although it's a little bit, you know, a lot of scaffolding on that now. But it's really an honor to be back here. And I definitely want to acknowledge UW and the Space Grant Consortium, which was a scholarship, is still a scholarship program that NASA sponsors that enabled me to attend here and also do research. And it was doing research, and the mentor that I had here, shown in the upper left here, who really actually introduced me to what physics was. Otherwise, I was pretty sure it was just something invented to torture me. But it actually is really cool, and what I'm talking about here today is largely space physics. So we can go out and sample what's going on, and it's a little bit closer in than all of astrophysics and astronomy. But I also want to give a land acknowledgement. Very grateful for the people who've taken care of the planet for millennia and are still here. I am fortunate to be living in Walla Walla now, homelands of the Cayuse, Umatilla, and Walla Walla tribes. And here we are in the homelands of the Coast Salish people. So I also want to acknowledge that I'm going to be speaking mainly from a Western science perspective about aurora, but there are many different perspectives that, that we want to know about and are very valuable. So a few more pictures about introduction to what I've done. I actually have worked on instruments that fly into space, both on rockets. That's what I worked on here at UW over in Johnson Hall. They don't do that very much anymore here. They still do some of it, but work on rockets that fly above the northern lights and sample the particles that cause those lights. And then I went to grad school to do the same kind of thing. And then I graduated and went to Los Alamos National Lab, where I worked on similar instruments, but for satellites in the Earth's near-Earth space environment. So you can't go up there and fix these things, so you really have to test them down here in a lab. And all of that data that we get is critical for understanding this kind of constantly changing space environment that we live in, that we can actually see from mainly the northern areas as the northern lights. And also sometimes we can see at other times, and sometimes it affects our technologies too. So it's really important to understand. So now you know a little bit about me, and I'd love to learn a little bit about you. So please raise your hand if you have seen the aurora before. Oh, we have a great audience of maybe half the people have seen the aurora. And many people in my own field have not actually seen the aurora. So could you raise your hand if you've encountered citizen science before? Oh, we also have a really strong citizen science audience here. Great. Has anyone here taken part in citizen science with auroras? Yay, a few people. Thank you. That's excellent. And that means the rest of you can do that too. And we all love nature. Does helping with scientific research sound fun? Yes, awesome, awesome, awesome. So you have definitely got what it takes to be a citizen scientist. And what does that mean? In case you haven't heard about that before, that's a way that basically people can go outside and they can use maybe a smartphone to record some observations. It could be observations of birds or plants or something that you love outside. It could be rocks. These are some observations from the area where I live of the birds on the Columbia River. And that's really neat to learn more about the birds. I'm just an amateur birder, but I am a citizen scientist for some of these projects. If you want to get more involved in these projects, there's a really great website called SciStarter, where you can find projects happening near you. You can connect with other scientists in those other fields who are wanting your help. And I recommend you check that out. But I'm going to tell you more about aurora now. So the aurora are kind of the end result of processes between the sun and the earth. Anybody know how far that is? It's 93 million miles. It's a really long way. So it's really hard to capture all of that dynamic environment. It's constantly changing. And the aurora is like the last thing that we see, that we can see of many steps that have to happen in between. So it's actually hard to tell you when you can go out and see aurora. That's one of the most common questions is, oh, it's so gorgeous, I just want to go see it. But unfortunately, that answer is very difficult. You have to really know what the different factors are and take your chances and weigh your chances as far as if you're going to go out and see it or not. What you can see in this movie is some of the dynamic plasma, the superheated gas coming off the sun. It can sometimes come towards Earth, a big amount of it. It can impact the Earth's magnetic field, which actually stretches and protects us from the harsh space environment. And as the Earth's magnetic field absorbs some of that energy, it can store it up but then release it towards the poles. And that's what we ultimately see as the northern lights. So I wanted to inspire you. This is an aurora chaser in Twisp, Washington. Kevin Nielsen, who captured all of this aurora and more during 2021, which was not really a big year for aurora. But I want to ask people in the audience, kind of looking at these pictures, what do you notice, or what questions do you have about the aurora from looking at all of these pictures that it's just one picture per night when he happened to capture it? What kind of trends are there? Any brave people out there? There are different colors. There are different colors on different nights.
Sometimes it's diffused, sometimes there's like color.
Yeah, sometimes there's more structure, and sometimes it's just super quiet. Yes?
Sometimes it looks like it's kind of faded.
Yeah.
Sometimes it's not as bright.
Yeah, sometimes it's really not very bright. And these are, photographs. And cameras are actually better than our eyes. So some of these were probably not visible to our naked eyes even, but the cameras can pick it up really nicely. Yes, in the back or behind him? Did you have something?
That was my question.
Oh,
You just answered it.
great. I just read your mind. Awesome. Any other thoughts about?
Oh, I just want to add that I've been learning from the Washington Aurora Chasers group, Facebook group, that the colors can actually show up on your smartphone. Have like a 10-second or 30-second exposure. But normally here in Washington, it's mostly white.
Yeah, it's absolutely true. The latest generation smartphones are good enough to pick up aurora now with their long exposures, and even some of them you might not need a tripod, but a tripod's still probably recommended for that. You need kind of a stable base to take that long exposure image. You don't want your stars to be blurry. Any other things people notice about this sort of set of pictures? Yes? Yeah, that's a great question. Do auroras happen in the daylight? So they do happen in the daylight, but we can't see them. Yeah. So, and there are some places that, like way up north, where it's dark at noon, that you can see auroras as well. Yes. Oh.
Use of observation. That's different times of the day. Night.
Yeah, and there's different sort of sky levels here. Some of them, there's some moonlight probably. Some have clouds. Why do you guys think this person was so great at capturing all this aurora? Maybe. Any thoughts, any guesses? They might sleep during the day. They might be in a quite nice clear sky. They're not in Western Washington. They're east of the mountains. Yes, what's your guess?
Their phones cameras are really strong.
They're a very good photographer. Yeah, this is not even a cell phone camera. This is a bigger camera. So they have a good camera and they know how to use it. They also happen, you can notice that these are mostly the same view. So they have a big advantage on all of us. They don't have to get in the car to see it. They're also up high. So they're up above the town, and you can check it if you know when the time is right. That's also a really nice advantage that some people have. And the rest of us, we just have to try harder and decide if it's worth it to go out or not. So, all right, great observations. About those colors, so the colors are caused by particles from space, mostly electrons actually, that are trapped in the Earth's magnetic field and have been energized by the energy from the sun. When they hit the very not dense upper atmosphere, that air, which is mostly oxygen, gives off these colors. And these rare transitions light coming out. First it excites the oxygen, and then when it de-excites, it causes these colors. Mainly for oxygen, it's green and red, and it takes different amount of time for those photons of light to come out, actually. So you don't see the red unless you're at the very, very highest altitude above Earth, because there's not many collisions there. But I have a little prop here. We'll see if it works. See which mode is more like it's sort of one of these modes. Well, the energy kind of comes down. I'm sorry, I'm not getting the right one, but you get the idea. And there's different colors, different emissions at different heights. Now we'll see if I can turn it off. Maybe not. Just put it away. Flashing light. All right. Hopefully that's not. Let me know if I really need to turn it off. There is a very nice little animation here made by a Canadian friend, Jeremy, who loves aurora and visualizing aurora, and he built this nice animation to show the layering of the different colors. And so actually the green is oxygen when those particles have made several collisions, and then there starts to be more and more oxygen. They lose all their energy at that layer, which is about 60 miles up, which is very, very high. It's like the edge of space. And sometimes the particles from space have more energy, and so they can actually go down into the next layer, which is nitrogen. And there, if you hit nitrogen, you get a little bit of pink. And that is really exciting to see. It's also very, very, all right. It's very, very fast, especially if you go up north and you see the aurora. It's a really good night if you can see some pink racing around at the bottom of the green. And then also there's a little bit of a nitrogen emission higher up that causes some blue as well. And those colors do mix. And then there's some of them are very dim, which to the naked eye will seem like kind of white or gray. And some people's eyes see them differently than other people's eyes as well. So some people can't really see the colors in the aurora very well. There are all these different types of aurora, and with our citizen science project, we do ask for a few of these types, if you know the type, to tell us, because it's really useful. Often you see different types during different times of the night and during different levels of activity. So there's kind of this characteristic buildup of activity, and first you sort of start with a quiet arc, kind of a quiet curtain, but then it can build up and get more active and race around the sky and be seen at lower latitudes, maybe not for very long though. And then that sort of small, we call it a substorm, that kind of recedes, and then the energy builds up again. And of course, this whole cycle is actually really varies a lot all the time. But those are some of the common characteristics. And sometimes, like after midnight, you can see these really ghostly sort of pulsating patches as well. That's very, very dim, but it is all of these really cool shapes. And that's caused by more complicated interactions than just the particles coming in and like hitting the atmosphere. They're being modulated, and we're still trying to understand all of the sources of that modulation, all of that variation to cause that kind of structure. And then there's something even crazier called Steve. Have any of you guys heard of Steve? Oh, a couple people have heard of Steve. So Steve, shown in the other side here, lower right. Steve is a new kind of aurora, unusual aurora that citizen scientists actually noticed, particularly a bunch of Canadians, mostly folks from Alberta. And they were out at night, and the aurora was far to the north, but there was something overhead that was sort of waving a little, and it looked like a plane going east to west, like a contrail from a plane. But when they took out their special cameras and they took long exposure photographs, like if you were going to take a photograph of the Milky Way, it lit up with these colors, this like purple color and occasionally this waving kind of green color. And so I'll tell you more about Steve, but that is something really, really exciting that citizen scientists helped to bring back to our attention so we could study it more, because we really didn't know what it was. Citizen science is also really useful in this sort of vast space because we only have a few satellites that can help give us good data on how much energy is coming from the sun. And another really important factor that you might have heard of is what's the magnetic field direction. And the energy coming from the sun has with it a magnetic field. And magnets, you know, they can oppose or repel, they can attract or repel. And if the magnetic field is attractive to the Earth's magnetic field, way out in space, kind of in this midway point, then that energy will be transferred more effectively, and we'll get better aurora. But if the sense of the magnetic field is not correct, which we call BZ is north or positive, that's not favorable. So people talk about that a lot, and I can talk more about that if you would like. But really, there's a lot of space, and so our forecasts are quite a ways behind, like weather, normal weather on Earth forecasts. So yeah, we've already covered most of these. How can you see aurora? You could go further up north, underneath sort of the everyday auroral oval that's always there, even if it's daytime. The Earth is kind of rotating under that. And if you do go way up north, you should actually not go when it's summer in the far north and when it's daytime all around, because you won't see it. But you also want to have a dark sky view, a clear view. You can check the space weather forecast for how that activity is shaping up, and the usual weather forecasts as well. There are a lot of aurora chaser groups, both locally, and Washington State has a great group. And in other places you could go, like Fairbanks. Yeah, so it can take a lot of trying and patience as well. I want to also show this photo is taken by a student of mine from the University of North Dakota, and he was an aurora chaser as a teenager, has gone to college, studied physics, recently graduated there, and astronomy. And as part of his intern project, he put up some cameras on YouTube for kind of fixed views of the aurora over North Dakota, which is more prevalent than you would think. So you can check out that camera. It's called NODAC, N-O-D-D-A-C, on YouTube if you want. And we have like blog posts about all of this kind of stuff on the Aurorasaurus webpage. So if you want to learn more about any of these, a lot of these kinds of things, we've done a blog post about it probably. This is another sort of comparison of what the aurora can look like to your eyes and to the camera. Let's see. And yes, here's the blog post itself, and even the North Dakota dual aurora camera system right there on our Aurorasaurus blog. We also have more background on what kind of the basic parts about what causes the aurora. And what can auroras tell us? So in our field, they can tell us both really practical things that you need to know for operating satellites and also for technologies on Earth, power systems especially. GPS, other technologies are affected by all of this space weather that the aurora is part of. And then they also indicate, you know, if we look far out in space and see planets with aurora, that indicates some really important things about the atmosphere and the magnetic field of those planets, which are quite critical to how we can live here and help us learn about where we could live or where there could be life out there as well. Okay, so now a little bit more about the story of Steve. There's actually a lot of stories about Steve. There's a whole small Canadian documentary called Chasing Steve. And I'm just going to play this little movie here with some of the story.
People were out observing the
You guys hear
aurora,
that out there?
and they started noticing something that was overhead as well when they were seeing the aurora far to the northern regions. It was unlike most aurora. Talked to the scientists, we didn't know what it was, and together they said, we'll keep taking observations and we'll call it Steve in the meantime. Steve is mostly a very narrow purple arc, and sometimes it has these little green features that go along with it as well that are kind of like waving fingers or a picket fence. That means that there's plasma physics happening up there to cause that light and to make these little discrete features that we don't understand yet. We now have some satellite observations from the ESA satellite called SWARM that show that Steve optically is associated with a very strong flow in the particles in the ionosphere, the upper level of our atmosphere. Steve is important for a number of reasons. It's really exciting that people armed with cameras all over the globe can capture something that we didn't fully understand and shed new light on that. It's also really exciting that this happens further to the south where there are more people, so it might be a kind of aurora that more people can see than the usual kind. We're now able to look up at the sky and see things about the aurora and this sub-auroral region that we never understood before, and then we can correlate that with our traditional observations and lead to greater understanding.
So all of this wouldn't have been possible without many, many images from people. And you can join the search. That video really wants to finish playing. Okay. It's hard. I haven't given talks in a while, so forget how things go. But these are some of the citizen science images of Steve. This from the Alberta Aurora Chasers, and you can see all of the many different perspectives, and you can imagine how those different perspectives help us to understand these very fine features and track better like exactly what's happening up there. These are all different events. And just to point out that people, when they take data, they take it in all kinds of different ways, which is actually stronger. It can be stronger than our traditional science observations, which tend to look in one specific way. So you might be able to discover something new when you look in a different way. But just to tell you that all of these images, the actual arc is mostly east to west, largely east to west. Do you have a question?
Yes. One of them looks like it's taken from today.
Oh, well, we'd have to talk about which one that is.
It's the one with the light here. It's down to.
Down to, like this one? Yeah, sometimes
Yeah. This one next to it.
sometimes it's the moon can be really bright, and just the exposure of the image can be brighter. So that's another thing that when you have citizen scientists taking images, you can, well, usually we like to work with the raw image that the camera has taken and not manipulated it, but people can, they can adjust the way it looks. And some of the cameras, they can be so sensitive that it's like a night sky image, but like night vision, it can look like it's day practically. So one really exciting thing that we also uncovered by working with a amateur professional aurora historian in Germany is that actually Steve is not totally new. Steve was seen by a very famous Norwegian scientist, Carl Stormer, and his team 100 years ago. And this image is what they were using in the technology of the time to take photographs. And he was very famous for taking some of the first photographs of aurora from multiple locations. And then you compare the stars in two different sets of photographs, and you can actually calculate the height of these arcs. And he did this so well that he cataloged the height of many different auroras, and types of aurora. And so he knew that this was a weird arc, and it actually has a different altitude than usual arcs. And so he described these as feeble homogeneous arcs of great altitude. They're kind of twice as high, and they are this this east to west stream of particles. So he really did a lot of work on them to the extent that of technology that he could use. And you can see there are some similarities in those black and white photos to modern photos of Steve, and the rest of the description is very similar too. But there's still a lot that's really unknown about and unusual, very unusual about these little green features also. So they go against what we think of as aurora, which is that the energy is deposited in a regular way. We actually can see tiny little emissions of light along with these. And so we're starting to investigate those as well. Yeah, and it really depends on the perspective, where you can look, or how it looks, excuse me. So if you want to follow along with Steve, Steve also has a Twitter account and reports regularly when they are seen. And to tell you more about Aurorasaurus, so our project is a way that people can report sightings and also get alerts of when aurora might be visible near you. And there's two kinds of alerts. One is when the model, which is this kind of coarse green broad area, would say that you're in a region you might be able to see aurora. And then the second alert is based on people around you reporting. And so citizen scientists can help trigger that alert by getting to a critical mass of people reporting. And you can go to the website and submit an observation, or you can just tweet. And if you just tweet, it's very helpful to say something like, I just saw aurora in Puyallup or Covington Park or wherever it is, because we actually need to find the location of the tweet. And we have a whole set of software that goes through and extracts locations from the text of the tweet. And then if you're on the website, you can also help us upvote those real tweets that have a really good location with them. And when all of that works during a storm, you get a bunch of observations. This is kind of a little movie about people's observations. On our website as well, there's a plot that you can see that basically tells you how strong the auroral activity is right now. It's called the solar wind power plot. The solar wind power is what's coming from the sun before it hits the earth. But this is the data from the one satellite that we have that's kind of our buoy out there to tell us what's going to hit us. And that gives us only about 1 hour warning of how strong that activity will be, how much the aurora could, where the aurora could show up. But 1 hour is more accurate. What usually happens is that something big happens on the sun, and then it gets really hyped in the media, and then it may or may not deliver when it comes here on Earth. And we don't, it's hard to tell because we're not able to measure that magnetic field until it gets here. So that's why it's I would say, better to wait until you get about the 1 hour warning. What makes a really good citizen science photo? This is an extraordinary citizen science photo by Donna from Manitoba. She captured a number of things in this photo. Anyone see any of the really unusual things in the photo? Yeah, this was Comet Neowise. What else? Yeah, this is the ISS, some active aurora. There's a little bit of a Steve here. She even, earlier in the same night, she had some noctilucent clouds as well, which are night shining clouds that you can see like after sunset. And so she had some of those and some aurora, and this is all one exposure. So it's really, really cool. And then, as Nancy pointed out earlier, this is really a great time for auroral imaging for aurora citizen science, because the sun is getting more active. The sun's activity actually changes on an 11-year solar cycle. And right now we're coming up towards that maximum. That'll be around 2025. So there will be more and more opportunities to see aurora, even down here in Washington. And people are all going to have smartphones that can actually capture that. So we definitely want to utilize those to help other people get better alerts and help look into the science of some of these very rare things that are happening with the aurora that we still want to understand, like Steve. And NASA is also encouraging citizen science as well. So all of that is working together. And I have lots of other resources depending on what you want. There's resources for kids from a podcast called Wow in the World, kind of kids under 10. There's a great video from the University of Alaska Fairbanks by the meaning of the aurora and interviews with elders, Inupiaq elders up there. So that's really great to check out. And then there are students who've studied Steve even for their, science fair, award-winning science fair as well. So thank you all very much. I'm happy to take some questions. Yes.
All the photos show the view looking towards the horizon. Can you look at auroras straight up?
Yes. So I'm going to repeat the question. The question is, can you see the aurora straight up? And yes, you can. But from around here, you need a bigger show. So the aurora, when it gets more active, it'll really come from the north and like 5 or 10 degrees off the horizon, more and more to overhead. So those larger events that will do that are more rare. We haven't had a whole lot of those lately, but yeah, that's when the data are really strong. It can definitely be seen overhead, even in the northern US states as well, and especially if you go quite a bit further north to the middle of Alaska or somewhere like that. Yeah. Yes? Yeah, so a lot of other planets have aurora and different types of aurora and even different types of magnetic fields. And, Jupiter and Saturn have these huge magnetospheres with moons that have plasma signatures in the atmosphere and all kinds of stuff. So there's models of how all of that works, and then some satellites that have gone out to study those regions around different planets as well. So, and we don't have great information on some of the planets and their aurora. Some we've just barely, scooted by. Yeah. Yes. KP levels. Who wants to hear about KP levels? Everybody. All right. So the KP is the Planetary K Index, which is a global index of activity. And so it's a scale that goes from 0 to 9. Historically, it was in 3-hour intervals based on readings from instruments that sense the magnetic field at Earth. And so you put that data together from those instruments all over the globe, and it converts into this index of how active it is. KP9 is going to be some kind of overhead aurora way down south, and those events are very rare. When it hits that level, it's going to be quite short. There's also all kinds of proxies for KP, estimates, other ways you can estimate KP, including from the buoy satellite. And then there's other apps and things that have very, very rough estimates of what KP is going to be. But you really can't know until an hour ahead of time. So most of those estimates are to be used with many, many grains of salt. Yeah. So, yes?
Have you heard any stories of hearing?
Yes. Have I ever heard stories of hearing the aurora? That's a great one. There are many stories about that. And then there are equally many stories about sort of scientists going out and like failing to observe that. I think it would be a great opportunity or a great experiment for citizen scientists, possibly, because some people are in really quiet places where they could spend more time and maybe have the equipment to capture something. And then there are some recent reports about different theories of weather and much lower altitude kinds of ways that sound could be produced. I think the jury is still out a little bit on that, but I think progress is being made.
Yeah, I wonder if what kind of equipment would you use?
You might know better than me, but I mean, really, you want to be in a very quiet place, having very low noise equipment. So,
Mhm. But it was a model. It sounded like crackle inside your head.
oh yeah.
So it sounded like it might be electromagnetic.
So
I don't know how to capture it.
there are also instruments that measure the electromagnetic waves in space and on the ground, and in different frequency ranges. So you can have different instruments tuned for different frequency ranges. And then, but that's not often translatable into like what you actually, what we can hear inside our heads. And then sometimes you're out there seeing it and your eyes can be playing tricks on you too. Like it's really interesting to try to, you could set up experiments where multiple people in different places are reporting at the same time and, kind of have have that. But I tend to think it's possible, but just very difficult to record. Yeah.
Don't these large geomagnetic storms create a ground current?
Yeah.
Could that be part of it? Could that be what's generating sound?
It is possible that could be inducing some sound in some other wires or buzzing or something like that. That's not where most of the reports are.
No, I can.
Yeah.
Could there be a correlation between aurora and
Can I ask you a question?
There could be. I don't actually have too much more to say on that, so we can talk more though. But I would love to take a question from online. Go for it.
Can you see aurora through a telescope or any other magnifying device that someone low vision like myself could experience aurora?
Yes, that's a great question. So you can. I wouldn't necessarily recommend a telescope, because you're getting a very narrow field of view there. But I think that is possible, actually, that someone would be setting it up to look at small features, and then that would be easier to see. But actually, I think what you want is more like a night vision scope. And there are night vision scopes that that are for different purposes, but they all have photon multiplying silicon in them. And so that, I think, could help potentially. So that's how some of the instruments work as well, that count the particles, because there's very, very few particles. So those instruments, those particles go into a, it's called a microchannel plate device that multiplies that signal by 1,000,000 times, and then it can be actually recordable as well.
Oh, you said a night scope?
Yeah. Yep.
Okay. Thank you.
Yeah, great. Thanks. I can't really see the chat, so I'm going to see if anybody else wants to jump in. And we also are running out of time. We have maybe 1 or 2 more questions out here in the audience. But is there anybody else online? Okay. Okay. 1 more question from the audience in the back.
Most aurora being visible either far north or far south.
Mm-hmm.
Haven't that recently some sort of equatorial phenomenon that's been recently observed, discovered?
Yeah, you might have been hearing about Steve, which is definitely seen farther south. And there's another kind of more equatorial, or we call it also sub-auroral latitudes. There's some other types of aurora, a SAR arc, which tends to be more red and is more rare. And then there's also something that was discovered by citizen scientists in Finland called a dune aurora. So yeah, the dune definitely is written up on our website and our blog, so you might be interested in that too. But yeah, the Steve that's one of its characteristics, is that it's way further south than the usual aurora. And it has been seen from both hemispheres for sure. So thanks for mentioning that too. Yeah. All right. Final question.
Easy question.
Sure.
Do you need any special filters for the cameras?
You don't need special filters. Yeah, you could, but you definitely don't need special filters. Some of the science filters, because they're calibrated, they are filtered to the specific wavelengths of the green and the red, and they use those specific narrow bands to correlate to how strong the aurora actually is. But just to take photos, yeah, you don't. Although I should also say that I am not the expert aurora photographer, so that's another talk, probably another group also. But thank you all very much. I can stick around a little bit if you have more questions. Thanks.
Use Tampa Scout at all?
Oh yeah, Tampa is great.
Well, of course, I enjoy photos.
Yes. Yeah. No, I should have mentioned those resources too. Sorry. Tamitha is great. Spaceweather.com is great. Yes.
Liz,
I have a resource page, so
can
yes.
I actually maybe get your autograph?
Sure. Let me close this down and say goodbye to the people online, or I don't know if I'm supposed to. I think I'll mute it at least.